Hi everybody. So now I want to talk about work. So basically work is like another way of looking at energy. Um, it takes a certain amount of work maybe to like walk upstairs, right? Or to carry something upstairs, right? You're sort of like taking force over a certain distance. That being said, the formula for work is given by, so work is denoted by W, FD cosine theta. So you'd also know like it's F dot D, right? But like you can take that with FD cosine theta. So this is force. This is like the force that's being applied over a certain distance. This is the distance that force is being applied over, and then you're gonna multiply it by the cosine of the angle from the start point, between the start point and the end point. Okay, so that's your work. Work can also be described by this formula, P delta V. And this V is volume. You're gonna find this in maybe like systems such as like piston cylinders, right? So or like even like you can think about it like a water bottle, right? Work is being done on the system when you're like compressing, like when you squeeze a water bottle, right? But if somehow the water bottle could expand, that it would be doing work on its surroundings, right? You're also able to calculate like work with like things we call PV diagrams. So let's say I have like a diagram, right? This P stands for pressure. Oh, and I forgot to mention that P stands for pressure, not like power or something. And then it's multiplied by the volume, the change in volume of something. So that's what that P delta V stands for. This is V, this is P, right? So like let's say I have something that follows like this path, right? If I wanted to calculate the work from point 1 to point 2, I would just take the area under the curve, right? It's like you're gonna be given things like a lot of the time maybe that look like sort of straight lines, so you can sort of like calculate what is going on, but like so a lot of the time you might see something like this. Literally, like to calculate the work done, it's just the area. So you would just multiply this height times this width, and you get the area, which would give you like the work, right? Integration is sort of what comes in when like it's not really constant pressure, or like even if you had, I mean, it doesn't have to be like integration all the time, honestly. Even if you had something that looks like this, right? We know how to take the work of this. You might divide this into like two shapes. Take the area of the triangle, right? Calculate that. Take the area of the rectangle, calculate that, add them together. That would be your total work. It would just be the area under the curve, of course. Power. Power is denoted also with the letter P. So power, right? Your power is going to be given by the formula E over T. Yeah, so it's like energy over time, but it's also maybe like work over time, right? So the work done over time, right? That's also power. And power is given by, here, let's see. Force would be like Newton meters per second. That's joules. Power, sorry, it's watts. So Newton meters is what denotes like a Newton meter is like also like work, right? And then if you divide that by time, it's a second. So we denote like a joule per second as a watt. And that's denoted by W. So that's the unit of power, W. We also have something called the work energy theorem, which just basically says that like the work done can also be calculated work done can also be calculated by the change in kinetic energy. So obviously that's K final minus K initial. So that can also be used to calculate your work. These are just good concepts to know in the sense of maybe when you're asked to solve problems, you don't really know. You have a few different formulas for work, so maybe one of them will work if the others don't. But yeah, if anything was unclear, please go ahead and leave it in the comment section, and let's keep learning, okay? Thanks.